Welcome back. Now I'd like us to go all the way to the end of the room into this next room over, where we have two platforms. One says hit callbacks and the other says overlap callbacks. We're going to test these out. Now we have some experience with onComponent hit and onComponent begin overlap. We're just going to analyze them a little bit in this video. Now in front of this wall, we have this actor. If I right-click on it and edit it, we see that it's called BP ball, add actor world offset tick hit. If I open this actor, I can first take a look at its class settings and see that it's based on the parent class BP ball add actor world offset tick. Now I can find that. Here it is. And we can see that in tick, all it does, if should move is true, is we call add actor world offset and pass in should sweep, which is exposed, so we can turn that on or off. So we're just using the add actor world offset. And as we know, we cannot detect a blocking hit unless we're using sweeping, right? So that's what we're doing. And in the child class on begin play, we're binding an event to the ball mesh onComponent hit delegate. And all we're doing here is spawning a system at location, so a Niagara system, and spawning a sound at location, as well as destroying the actor. So we have some visual and sound effects that will happen in response to a hit event. Now, the ball mesh here is using SM Sphere 30. And if we open up SM Sphere 30, we can make sure that the collision presets are set appropriately. Now, if you've messed with this already, let's just make sure we're all on the same page here. We have collision enabled set to collision enabled query and physics. Object type is world static, and responses to all channels are block. Now, in other words, this is the same as the collision preset block all. So we could just set it to that. Now, here in the level, we can make sure that this actor has its ball mesh set to the same collision presets. They're not overridden. And we can see that they're set to default, so it's using the presets for the mesh. Now let's take a look at that should sweep Boolean variable. We'll have to select BP ball add actor world offset tick hit self. In order to see that variable, we see should sweep, and it's set to false, it's unchecked. So if I press play and I let that ball fly into the wall, nothing will happen. We don't get our hit callback, because we're not sweeping, and we're using add actor world offset here. So if we want to register a blocking hit and get that hit callback, we need to enable sweeping, so we can check that checkbox, press play, and there we go. We get our explosion, particles, and our sound, and our hit callback is clearly working. So it's just a testament to the fact that using add actor world offset or set actor location is directly setting the location of this actor, and that's going to require sweeping if we want to detect those collisions and get those hit callbacks. Now, another thing to note is that a hit callback is in response to a blocking collision interaction. If instead the collision interaction is overlap or ignore, we will not get that hit callback. And we can prove that by first taking a look at this wall, selecting its static mesh component and looking at its collision presets. We see that it's set to default. So to see those default settings, we have to go to the static mesh asset. So we can scroll up to static mesh, browse to that and open it up and take a look at the collision presets here. And as we can see, it's set to block all. So its responses to all collision object types is block. So if we wanted our collision interaction to be something other than block, at least one of these components interacting must have either overlap or ignore to the other component's object type. We know that both of these has collision object type world static. So what I can do is go into my SM sphere, change its collision presets back to custom so I can change them, and set its response to world static to, say, overlap. If I do that, then I no longer expect to get that hit event. Let's play test and make sure. And sure enough, we did not get the hit event, but if we look back there, it got the hit event against the wall. And that's because the wall has a different collision object type. So remember, we always take the least blocking interaction between two colliding components. The sphere has its response to world static set to overlap, and even though the wall has its response to world static set to block, the least blocking of these two interactions is overlap. So we do not get a blocking interaction when our sphere collides with another object whose object type is world static. I'm going to go ahead and set that back to block. Now for overlap events, we need an overlap interaction. So if we come back over here to our left, we can see that this actor is a different class. We can right-click on it and see that it's a ball add actor world offset tick overlap. If we go to this one, we'll see that we have an overlap event, an event bound to onComponent begin overlap. And what we're doing here is checking the onComponent begin overlap event from sweep Boolean. You see, this Boolean will be true or false depending on whether or not the overlap event is the result of sweeping. So here our ball mesh is using SM Sphere 30 and its collision presets is not overridden. So SM Sphere 30 is still world static and still has a blocking response to all and is using query and physics. It's pointed towards this box here. So let's take a look at the box. It's an actor of type BP trigger volume. So I'm going to open this BP trigger volume blueprint and see what we've got going on here. We have a box. Now this is a box component. It's blue because the shape color is a property that can be changed from within this blueprint. Now let's take a look at the collision settings for the box component. We'll scroll down and see that its collision presets is the overlap all dynamic collision preset, which means that its collision enabled is set to query only, no physics collision. Its object type is world dynamic, and its responses to all collision types is overlap. Now, because the box has a collision response to world static set to overlap, we can then go and look at the sphere and see that its collision object type is world static. So the box component's response to world static is overlap, but we also have to go the other way and see what the sphere's response to world dynamic is, because that box has object type world dynamic. Now the sphere's response to world dynamic is block. So we have two conflicting responses. We have block and we have overlap. Well, we always take the least blocking interaction. Between overlap and block, the least blocking interaction is overlap. So the resulting collision interaction is overlap. So we expect our overlap event to be triggered. And what happens here depends on that from sweep Boolean. If it's true, we'll get a blue debug sphere at the impact point from that sweep result, as sweeping generates a hit result. If from sweep is false, then we'll just get an orange debug sphere at the actor location for this BP ball. So let's go into our level and select this actor and see what its should sweep Boolean is set to. Looks like it's set to true. So let's press play. And there we have it. We get our blue debug sphere, which means if we look at our actor, the blue debug sphere is the result of sweeping. And we drew it at the impact point from that sweep result. Now let's disable sweeping for this actor by unchecking should sweep, and let's see what happens then. And we get our orange debug sphere at the location of our BP ball at the point of impact. So notice the difference. In the case where from sweep was false, we drew the debug sphere at the actor location, and that's because if from sweep is false, then the sweep result, hit result, does not have any valid data in it. It's only filled with valid data if this overlap event is the result of sweeping. And we can't have an overlap event resulting from a sweep if we're not sweeping, right? So we have to sweep if we want our overlap event to have valid data in its sweep result, hit result. Note that we will not get an overlap event if our collision interaction is any type other than overlap. For instance, if we open up our trigger volume, select our box, and set its collision presets to custom so we can change our responses, and if we change our response to world static to block, well, now the interaction will be block and not overlap. Let's see what happens in that case. Notice that our ball stops in its tracks. It cannot pass through the box. If instead we take our box and set its collision response to world static to ignore, well, let's see what happens in that case. Notice the ball passes straight through, and we did not get our debug spheres because we did not get our overlap event called, and that's because we did not get an overlap interaction. There was no collision interaction. The resulting collision interaction was ignore. So our trigger volume needs to overlap the world static object type to get an overlap interaction. And that's because our sphere has its response to the box's object type, world dynamic, set to block. Now, before we wrap up, it's worth noting that for overlap events to be generated, both components have to have a particular Boolean set to true. That Boolean is called generate overlap events. This has to be true on both components that are overlapping. That means the BP ball as well as the trigger box must have this Boolean property set to true, generate overlap events. If one of these components does not have generate overlap events set to true, then we will not generate overlap events. And just to prove that, we'll take our ball mesh on the BP ball here and uncheck generate overlap events and press play. And we'll see that we don't get any debug spheres. And if we set that back to true, we will get debug spheres. And there they are. Now, it's also worth noting that for hit events, there's a Boolean called simulation generates hit events. Now, if I select this ball mesh here, notice that this Boolean is not true. That's because it's not needed for hit events unless those hit events are the result of physics simulation. Let me show you what I mean. I'm going to grab one of these actors that are using physics, our add force ball. I'm going to bring it up next to our wall here, and I'm going to right click and edit this BP ball add force, and I'd like to bind an event to its on component hit delegate. So I'm going to get the ball mesh, search for on component hit, and assign a new event to that. And we'll simply draw a debug sphere. And we'll draw it at the impact point of the hit. So I'm going to break our hit result, get the impact point, and draw the debug sphere at that impact point. We'll draw it with a green color for a duration of 60 seconds. And the radius can be 50. So now I'm going to take this ball, select its ball mesh, and override its collision presets so that it's only using physics. So I'll set it to custom, and I'm going to set collision enabled to physics only, no query collision. Its responses to all types will be block. And I'm going to play test this, but first I'm going to delete the other ball. So we're just dealing with our physics ball here. I'm going to press play. And we do get a blocking interaction, but we did not get our debug sphere. That's because we're only using physics, not queries. So this ball mesh needs to have simulation generates hit events set to true in order to get that hit event. If I press play, there's the debug sphere. We got it as a result of the hit event. because our ball mesh has simulation generates hit events set to true. This does not need to be set to true if that hit event is the result of a blocking collision from sweeping, which uses the query system. If we're using the physics system, we need to set simulation generates hit events to true in order to get hit events. And the last thing I'm going to demonstrate is probing. If I set collision enabled instead to probe only, no query or physics collision, and I set simulation generates hit events to true, we're using the physics system now, but we don't expect to see that ball bounce off of the wall. It should pass straight through, but we should still get our hit event. Let's see what happens. And there we go. We got our hit event, actually multiple hit events, as we got it spammed a little bit because our ball was continuing to pass through that wall. So that's something to be aware of. Hit events can be triggered multiple times during the period of contact. So probing is good for generating those hit events, getting those callbacks called in response, but we don't get physics interactions such as preventing the ball from overlapping and sending it bouncing in the other direction. For that, we actually need physics, so we would need to set collision enabled to physics only or collision enabled query and physics. And of course, query and probe allows for probing and queries if you need that too. All right, excellent job, and I'll see you in the next video.